So now in this video, we're coming back to the op amp. I did a longer video, last video, where I kind of reviewed pretty much all the topics dealing with an op amp wired as a comparator. So now, instead of using the trim pot as our signal, we are going to use a light dependent resistor and then a fixed resistor to make a voltage divider. It's a variable voltage divider, but this time the main thing depends on how much light is falling on it, and you can adjust the sensitivity with that value resistor as well. But with the trim pot, if you have the supply rails across the two power pins, you set it halfway. It's just halfway the supply voltage. But it's easy to see where I turn the arrow and everything, whereas you can't really get a sense of how much light is falling on the light dependent resistor. But here we kind of change that. So here you notice we have our fixed voltage to the inverting input, which makes it a non-inverting comparator because the output's going to be more like what we got at the signal there based on the light dependent resistor for the most part. And so it's non-inverting, output's going to be more like our signal. We could use the trim pot there to adjust where that signal falls. Otherwise, to adjust sensitivity, we have to swap this resistor out. We'll probably come back a little bit later. So we'll kind of zoom in there. You can see the pin layout. You have to power the integrated circuit. I tied the unused inputs to a supply voltage to help stabilize things. If you don't add those, it probably won't affect the circuit. So a lot of times I don't add them just because people be wondering like why are those there. But in any case, you should always tie the unused inputs to a supply voltage, not the output though. Output provides power. You don't want some way for it to go to a different power source. But we have a pin 8 to the positive supply, got to power it, and then pin 4 to the negative supply. So you can see that, or ground. This is ground because it's a single supply. We have a positive voltage and a negative voltage, and that's the only two reference voltages we're working for. So 0 volts, 5 volts because I have the power supply set to 5 volts. Now, the inverting input there is above the non-inverting. That's minus, that's plus on the physical component. Here you can see it's the opposite on the schematic, and I included the pin numbers there, so hopefully that's helpful. But in any case, whatever is written on here doesn't matter. You have to make sure that this circuitry goes to the non-inverting input, which is down lower. So that's where you see the light dependent resistor and the 3K resistor on this circuit. Even though it's higher on the schematic, you got to make sure you shuffle things so that they line up with the physical component. So now we got it dark enough, the output got low, and in fact the way I have this set up right now, this is an old schematic, and I at first wanted to use a 10K resistor down there, but in any case I would have had to turn the lamp off that much if we had a 10K resistor down here. I didn't mean to turn that lamp all the way off. So there's the brightest setting for this lamp, and there's the next setting lower. So it's barely darker, but it's right at that borderline right there. And of course, the darker I get it, it's going to stay low. And the brighter I get it, from this point, it's going to stay high. So now we have enough light falling on the light dependent resistor. We set half the supply voltage there. So this is less than 3,000 ohms of resistance because we got 3,000 down there. So light, it's pulling the voltage up above 2.5 volts, closer to 5 volts than 0 volts. And I get it just a tad darker there. Now it's slightly more than 3,000, that light dependent resistor. So the voltage is being pulled a little bit down towards ground right there. And we can use a flashlight as well, which will get a lot brighter. So I'm going to set the side light on because the main light turns on and off rapidly. So especially when there's no other outside light, they'll look like both LEDs are on at the same time for a short period. But yeah, there you can see I can use a light that is quite a bit brighter than the overhead lamp. And now I'm going to do that front light again and kind of move it. You'll be able to see that it looks like they are both on. There we go, right there, but they're not actually both on. It's just turning on and off. The light's turning on and off rapidly, so it's alternating which one is on, but they both look steadily on. If I really get close though, then it kind of overwhelms that turning on and off, and it's enough to keep the red LED on. And there is a little bit of delay if the light is strong enough or weak enough where even though the light's turning on and off rapidly, it'll prefer one or the other. But there's like a wide range where they'll both just kind of alternate rapidly because the light's turning on and off. And be less likely if the overhead lamp is also on. But in any case, there we go. We got it bright enough, output's high right there, dark enough, and the output is low. So again, we manipulated the signal, made the signal with the trim pot in like recent videos. That's generally what I do. But if we don't want to, if we want to like adjust this at any time, then we pick the 2 value resistors, or the resistor there, light dependent resistor that we want. And then instead of this voltage divider, we could use a trim pot to fine point the exact point where they change. But I didn't draw this on this schematic. I have other schematics where I did. So I'll make a future video with that where I swapped them out. So hopefully it makes more sense. But I also made old videos too. So just look up my op amp videos, and sooner or later you'll find a diagram, maybe in the picture that they show on the video. But you might not. But in case, it would be an adjustable sensitivity. Maybe I wrote non-inverting comparator. You can change this voltage there so that it lines up with whatever light level you want it to either be high or low. The light level where above it it's output's high, and below that light level the output is low. Hopefully that makes sense. So in any case, not going to make this video way too long. I'm going to end it there. Thanks for watching. Make sure you check out one of the other videos I posted to the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.